Okay, here's section 1.8, interpreting graphs and functions. And really quick before we even start, this kind of really mostly vocabulary, and it becomes it's pretty intuitive, but just knowing the vocab. And this is on page 57, just so you guys know. You can go there, and all the definitions are kind of laid out really nicely for you. Page 57. So here's kind of a similar one to that. So if we look at this first one of the line here, so this is a linear graph, right? And I'm using the black guy kind of lines are my functions, okay? So I'm looking at where is this function positive and where is this function negative? When I'm looking at positive and negative, and I say the function is positive, what I'm saying is that its y values or its output is positive, or if the function is negative, its y values or its output is negative, right? So we're looking at y values where they're positive and negative. So this function is positive, right, up here until it hits the y value hits 0, right? And this is all positive. The function is positive, and then we could say this from this x, like this interval, right, for this like portion right here. So for this portion of x values, or this like little subdomain, maybe it's like a little bit, the function itself, the y values or the output, like is positive. Okay, in terms of negative, where is it negative? Okay, well, it's 0, and then all the y values start to become negative here. So wherever it's below the x-axis. So above the x-axis, the function is positive. Below the x-axis, the function is negative. So that's our x-axis. We've been doing that green, and y-axis in red. I'll just rewrite those for you. Good. So that's positive and negative. That works for any functions. And then similarly, we could say from this other squiggly interval, the function's negative. Okay, moving on to the next one. This is increasing and decreasing here. Okay, so this function in black is increasing when it's going up, when it's going in the upward direction. It's decreasing, and sorry, let me mention this first, is that we are looking at the function as we tend toward the positive direction, from negative direction to positive. Okay, so we're looking at the function in this direction, and we look at it and say, okay, so let's just take a look at this one. So this one is going down, right, and around here. It's going down, it's going down, it's going down. So we say here the function is decreasing. And then again, we could specify, or we could like say from this little interval here, right? From these x values, the function is decreasing. Okay, and how about increasing? Well, when the function is going up, it's going toward more positive values, right? When it's going toward more positive values. And remember, we're talking about kind of slope. So increasing and decreasing is like the slope, sort of, right? Look at it that way, and we could do the same with the interval. So for this interval, dotted maybe, it's increasing. So increasing, going up. This one's pretty self-explanatory. Increasing, going up. Decreasing is going down. Just remember that you're going from left to right. All right, and then the next one here is relative max and relative min. Okay, relative maximum and relative minimum. And these are called also points of inflection, right? It's kind of where the graph does a dip, and it changes kind of which it's a U shape. If it changes a U shape from being an upward facing bowl versus a downward facing bowl. Okay, so and it's at the base of the bowl. So here would be a relative minimum. Okay, so on either side, you can see it's on the left side. So on this side, the function is decreasing, and then on the other side, the function is increasing. So that's what the definition behind relative min, relative max is. It's increasing on one side, decreasing on the other. Then that's what we get there. So relative, so that would be a relative minimum there. It's a relative minimum because the end of the bowl is facing downward. Okay, relative maximum is right here, and it's similarly, it's just the other way around, right? So we've got from this direction, the function is increasing. From this direction, the function is decreasing, right? And then we go, and finally there's one more relative minimum. So this one's a maximum, relative maximum. Let me make sure that's nice and clear for you. This one would be a relative maximum. This one is a relative minimum, and this one's another relative minimum. Okay, then we have end behavior, and all that is essentially just taking a look at what's happening at the end as this function keeps going to positive infinity this way and negative infinity this way. What happens to this function? Well, we know this one's going up. It's going up to, the y values are going up to positive infinity. And here this one's going down, the y values are going down, the y values are going down to negative infinity. So we would say the end behavior of this graph, for x approaches, as x approaches on the green, right, as x approaches negative infinity, our function approaches negative infinity. As x approaches positive infinity on this side, right, as x approaches positive infinity, y also approaches positive infinity. So we're just looking at the ends here and seeing how those work. Okay, let's look at one more example over here. Okay, so let's do all of these things in one. So I want to see where is the function positive, f of x is positive. Remember, we're looking at y values. Where is it positive? Okay, right here we have positive values for y. And then we have negatives, and then again we have positive here. So we have positive values for y at these two places. And negative values, y is negative here. Negative, and it becomes negative here. So we have negative values all through those regions, right? And we could, later on we'll worry about notating all this really nice and clearly, but just this is to get the idea. The next thing we have is increasing, decreasing. Okay, I'll use maybe red for increasing. Increasing. So where the slope, right, increasing, decreasing about slope, where the slope is positive or where the function is going up, it's going up. And remember, we're looking at the function from left to right, like reading a book. So it's increasing, or it's going up in this region right here for blue, and then here the slope is probably, it looks like it goes to 0, and it does, and we could talk about that later too. It goes to 0, and then it starts decreasing. Maybe orange for that one. Here. Okay, it's still negative slope. If you look at the slope, right? Negative, negative, negative. So it's decreasing on the orange line here. Decreasing, decreasing, decreasing. And then it looks like we have a 0 slope again here. And guess what? We're going back to increasing. The slope is positive here. The slope is positive. We're increasing, increasing. So this is really just to get a really good feel for our function. So increasing on the blue, decreasing on the orange. Nice. Okay, and then we have relative extrema, right? Is what they call it. Relative maximum. Where is there a high point and a low? Where is there a high dip? High point and a low point. So let's do those in red. So here's a high point, right, where the slope changes from being increasing to decreasing, and here's a low point where the slope changes from decreasing to increasing, right? You can see those are our relative. This guy's our relative max. This guy's our relative min, right? And then finally end behavior. Okay, so end behavior. Maybe we can do this in. I'm running out of colors. Green. Sorry, that's our x-axis. But we're going to circle our end behavior and see what's happening here. Well, in this case, as x, well, it's green. It's perfect because as x approaches negative infinity, as x goes to negative infinity, this direction, y. What is y doing? That's what we ask ourselves. Y is going also to negative numbers. It keeps getting more and more negative. Okay? And then the opposite, the other direction, as x approaches, so this is negative numbers for x, and this is positive numbers for x. As x approaches positive infinity, what happens here? Well, we're going up. We're going bigger and bigger and bigger, right? So positive y is positive infinity. So we would say the end behavior, as x approaches negative infinity, the function approaches in negative infinity. As x approaches positive infinity, the function approaches positive infinity, or diverges. You would say that too, but don't worry about the vocab so much. Just to, get the general idea here, and hopefully this was helpful. All right.